Good evening, my dear 26 and 2027 JEE aspirants. It's time to start the new chapter of collisions and moment, where you will see things are hitting, things are exploding, and you have to figure out with what speed, what energy losses, what's the momentum, what's the impulse, what is the force. All these kind of questions can come from this particular chapter. So it's not very big, but definitely conceptual. So a lot of concepts related to momentum and collisions is used in other chapters, be it electricity, magnetism, electromagnetism basically, or even sometimes in you can say fluids and other chapters as well. So it's time to start with momentum and collisions. We'll split it up into multiple lectures. Today we will focus on impulse, average force calculation, momentum and energy, and the basics of conservation of momentum. We will not do elastic, inelastic collisions today, oblique collisions, head-on collisions. Those kind of questions will not do it today. We are going to focus on the first part of the chapter. Is that okay? Because we go in detail. Hi Rama, welcome. Nice to see all of your comments. Hi Preet, Yogesh, welcome Anime. Hello, good evening, Hema. Good evening, Anime boy. Welcome, welcome. Everybody out there. Ipidi irukunga. Vanakkam. Yes, andariki namaskaram, namaskara. Ellaruge. Yeah, let's begin with the class. And if you have forgotten to like the video, please do that right away, right now. Why should you like the video? Sir, come on. Is teaching for free and you can't even like one video. I mean, really, I don't have to give you any explanation why you should like the video. I mean, it should come from the heart, it should come from within. Okay, and that is always a Guru Dakshina, and that always uh, should be there. Okay, so thank you for liking, thank you for subscribing if you have done that already. Cool. So let's begin. That was my introduction. In case you are new to the channel, please say hello, hi, from which city, which grade, what are you preparing for, and also mention in the comments as well. And if you have not yet registered for MVSAT, please do that right now, bro. Yeah, it's coming. MVSAT is coming just barely few days, 4th, 5th, 11th, 12th October. Not only are you getting all India ranks, you are getting a detailed report card, you are getting a chance for winning the scholarships from a big pool of 150 crores plus 2 crore worth of cash prizes in different forms, and also assured resources the moment you register. So it's happening in multiple cities. Check out the link which is there in the description box of this particular video. You will see the link is being pasted even in the comment section. You will probably see it. Okay, just click on this MVSAT registration link. It's very simple. All the details, FAQs are there, and it's for 11th, 12th, dropper, 10th, every student. So do that. Hardly any time is left. Okay, so just say register now and enter your details so that everything can be taken care of smoothly. Cool. So let's begin with the class and let's start with the concept of momentum, right? Thank you, JEE Aspirant. Thank you so much. Oh, this is, by the way, the new MVSAT shirt. I am loving it. I got nice gifts from the team, and I will show it to you. I'll make a short video on it. Okay, it's very nice. You will love it, and you will love it more because you are also going to get many such amazing things when you come to the center and register for the exam. So, when we talk about momentum, remember, just to quickly recap, momentum is the effect of mass and velocity. Momentum is the effect of mass and velocity. So if I have some object over here of certain mass, let's say m, and it is moving with some velocity, then the momentum also is in the same direction. Momentum symbol is p. Momentum and velocity are always in the same direction, and this momentum is nothing but mass times of velocity. This is one important formula which you should be aware of. Momentum is also related to the kinetic energy of the particle. So if I talk about the kinetic energy kinetic energy K. We have seen this before, but still I am writing it. I can obviously write it as half mv square. I can also write kinetic energy as half p square divided by m, because momentum is mv. So p square will become m square v square. One of the m will get cancelled and you will get back the same equation. If you want, you can rewrite this equation. You can rewrite this equation into different form like this. Take 2m over here, so it will become 2m into k, but that would be p square. So the momentum value will be root of 2 times m times of kinetic energy. Both are equivalent, so either this or that, one of them you should definitely remember. Okay, everybody with me? Yes. So some of you are also wondering whether it is a vector quantity or a scalar quantity. Obviously, it's a vector quantity in the direction of velocity, and the SI unit is kg meter per second. Okay, SI unit is kg meter per second standard. Momentum is also related to the force, net force acting on it, and that is by Newton's second law. So as per Newton's law of motion, as per the second Newton's law of motion, the net force, the net force acting on the particle, the net force acting on the particle is the rate of change of momentum, rate of the change of momentum. This is also very, very important. This is more like recap, guys. We have seen these formulas in work power energy chapter. We have seen this momentum in Newton's law, but some of you might be new. So that's why I'm just quickly revising through this. So if F represents my net force, then my net force, is nothing but rate of change of momentum. That means dp bar by dt. Now this dp bar by dt also suggests one more thing, that if at all I have been given with a graph of momentum versus time, it could be anything, some random curve, let's say, some random curve. If I draw a tangent to that particular curve at any given point, if I draw a tangent to that particular curve at that point, and I measure how much angle does the tangent make, then I can say that particular tan theta, which is rate of change of momentum, is nothing but the slope and is also the force. So of the slope of momentum versus time, the slope of momentum versus time graph is also going to give you the net force. What rate is it changing? If the momentum is constant, no force. If momentum is increasing, there is some force, okay, in the positive direction. So this is again something which is memorable. Okay, you have to keep it in your memory. Cool. Optics PDF not uploaded, Lama, is it? Okay, I will just inform the team and we'll get it uploaded. Cool. Hi, unknown prince. Welcome aboard. Yeah. Yeah, p square by 2m is an important formula, Ragul. Definitely, definitely it is. Let's do some questions on all these things so that you guys get an idea. Here is the first one. The figure represents the momentum time graph of a particle moving in a straight line or an axis under the influence of a force. Identify the region of the graph where the magnitude of the force is maximum and minimum respectively. Where is it maximum and where is it minimum? It is mentioned that T3 minus, not T square, it is T2. T3 minus T2, T3 minus T2. So this is less than this. That is what is mentioned. Okay, so this is less, this is slightly more. That is what they have given. So if I want the force to be maximum, the magnitude of that force, I'm not interested in the sign, I'm interested in the magnitude of that force. That means the slope should be maximum. The slope is basically maximum. Now where is the slope maximum? You can see it very easily. Come on guys, where do you think it is? Yeah, where do you think the slope is maximum? Yep. No, don't take area under the curve, Ragul. No area under the curve. See, that is a common mistake. Momentum versus time. Rate of change of momentum. Whenever the word rate, instantaneous, derivative, slope comes, it is related to calculus of slope or derivatives. Instantaneous rate of change. That is dp by dt. So not area. It is not integration. It is derivatives. So I think that the slope is maximum here. You can see maximum change is happening. You can see big change is happening in a small time interval. So definitely C should be maximum. So definitely it is happening in the C part. If you ask me, where is the magnitude of the force minimum, then it means the slope should be very small. The slope is minimum magnitude wise. Where do you think it is happening? Very slowly. No, this is more slope. This is very steep. This, I think, is a low slope because in so much time, it changed only this much. So the angle made is less, slope is less. So definitely it is in B. So maximum at C, minimum at B. So that is how it is. Maximum at C, minimum at B. Maximum at C, minimum at B. So the correct answer to this particular question is option 3. Is that okay? Very good. Yes. Not, I think first is maximum, next is minimum. Do not mark 2. Many people marked 2. No. B is minimum. B is minimum. The question is maximum and then minimum. So first alphabet or first answer should be for maximum, respectively word is used. So be careful. CB is the right answer, not B into C. Okay? Cool. Very good. Amazing. Amazing. Proud of all of you. Now, imagine I frame another question for all of you, and here it goes. It says the momentum, the momentum of a particle, the momentum of a particle increases by 300%. Find the change percent in kinetic energy. How much did the kinetic energy change by in percentage terms? So let's write down the initial things, whatever I know. Initial values. Initial values. So I know there will be some momentum. Let's say that momentum is P. Let's say that kinetic energy is K. And they both will be related to each other. Kinetic energy will be P square divided by 2m, of course. So these are all the original values. Now, let us see how much is the change in the value. How much is the change in the value? Change. How much is the change? It is clearly mentioned that the momentum increases by 300%. Now, 300% means what? Imagine if somebody asks you what is 50% of Shreyas sir, that means half of me, correct? If somebody says 25% of Shreyas sir means 1/4 of me. Somebody says 100% of Shreyas sir means one complete Shreyas sir. 200% of Shreyas sir means 2 times of Shreyas sir. 300% means 100%, 100%, 100%, 3 times. So it is 3 Shreyas sirs. So 300% of that momentum means basically 3p is that change. Got it? So what will be final value? What will be the final value of the momentum? P plus 3p, that will give me nothing but 4p. P plus 3p, the change, that will give me 4p. So what will be the new kinetic energy? What will be the new kinetic energy? It will be the new momentum, which is 4p whole square by 2m. Correct? 4 square is 16. So 16 multiplied by p square by 2m. But wait a minute. I know what is p square by 2m. That is nothing but my old kinetic energy. So the new kinetic energy is 16k. The new kinetic energy is 16k. But the question is, what is the percentage change in kinetic energy? So percentage change in the kinetic energy is how much is the change of the kinetic energy upon what is the initial value multiplied by 100. That is how percentage changes are calculated. You figure out how much have you changed and you divide it by the original initial value, and then you multiply, you scale it up to 100. That will give you in terms of percentage. Okay, the change is obviously 16k from its original value k, and initial value was obviously k, and multiplied by 100 over here. 16k minus k is 15k. So 15k by k multiplied by 100. Obviously, kk will get cancelled and we will get the answer as 1500%. So the answer is 1500%. Got it? Very good, SB, Rama. Amazing. Very good. Proud of all of you who got the right answer. Very good, Chinese world. Amazing. Amazing. Okay. Clear, Oragul. Okay. So this is how you can get some questions on either the slope or basic derivatives or just this kinetic energy and momentum relationship. This was fairly basic, but let's go to the main concept now, and that is impulse. And then we'll go to average force. Now, a lot of people get confused. Impulse, they think, is a force. Impulse is not a force. Impulse is a new quantity. It is not a force. Impulse is impulse. It is the change of momentum. Change of momentum. It is the change of momentum. That is one way of defining it. Or other way is it is the effect. It is the effect of a large force for a relatively small time. Now, there is no such rule, sir. How much force should it be? Large means 100 Newton, 200 Newton, nothing like that. It's like a qualitative thing. You can just say it is the effect of force and time, but large is compared to other forces occurring near it. So then it becomes large. And small means there is no thing like how small is small. Okay, there is no rule. 1 hour, 1 second, 1 minute. It depends again, what are you comparing it with? So the change of momentum or the effect of a force and time, that is basically your impulse. Okay. All right. Okay. Azad, my God, don't spoil the joke, man. Yo. I don't think you got the joke in that short. I did not. You apply your mind. What kind of history I was talking about? Okay. So now, what is the symbol for impulse? The symbol for impulse simply is usually J. Sometimes they use I. It's a vector quantity. Like I said, it is change in momentum. That means delta. Delta stands for change. P stands for momentum. That is as good as saying it is the final momentum minus the initial momentum. So that is your impulse. Very, very straightforward. Yes, it is a vector quantity. It is a vector quantity. You have to use vector subtraction, and the SI unit is same as momentum. So I can put kg meter per second. No harm in that. Kg meter per second. If you are given the vectors of momentum, initial and final, say for example, this is initial momentum. Let's say this is final momentum. Chumma, I'm taking some random values. This is initial momentum. Let's say this is final momentum. So if this is already given to me, then what I will do in order to solve the problem, I will have to take final as it is, take the negative of the initial momentum. So final momentum will be as it is. Okay, this vector will come as it is. Initial momentum, I will reverse it. Initial momentum, I will just reverse it. Maybe something like this, I believe. Okay, this is how it will be. So this is minus pi vector. This is final momentum vector. So now this is vector subtraction using triangle rule of vector subtraction. This if you connect, that's it. That will give me the impulse vector. So you have to use vector subtraction basically. All you have to do is Use vector subtraction. Is this absolutely clear? How you use vector subtraction to figure out how much the impulse is? Everybody with me? Perfecto? Amazing. Amazing. Sir, give me an example of this. Say for example, I tell you over here, example, there is some uh, zero point 0.2 kg mass which is going with a speed of maybe 4 meters per second, and it turns and goes like this, maybe with the speed of 3 meters per second because you hit it with a bat. So that particle or that ball or that object has changed the direction. So if I'm asked to figure out how much is that impulse, then I will say it is final minus initial momentum. Yes, I can use vector subtraction geometrically, or I can use IJK method. I suppose IJK method will be easier here. How? Final momentum, which is mass, which is 0.2 kilos, into velocity, which is 3, but it is in the y-axis, so 3 j cap. This is final. If you ask me initial, it will be mass, which is again 0.2, and velocity is 4, but in the I cap direction. So as you can see, this will be nothing but 0.2 into 4, which is 0.8. So minus 0.8 I cap. I cap usually is kept first. 2 3s are 6, so it will become plus 0.6 J cap kg meter per second. That is the answer. That is the impulse in vector form. If somebody asks you what is the magnitude of that impulse, then you just have to take this, which is 0.8 square plus 0.6 square. So this will be nothing but 0.64 plus 0.36, which is nothing but, oh, that is just going to be 1. So it's just going to be 1 kg meter per second magnitude wise. If magnitude is asked, if direction is asked, then we will write it in IJK form. Is that okay? Everyone? Awesome, 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 awesome. Very good, very good. Keep it up, guys. Sir, how numbers can be multiplied by unit vector? Ragul, please watch my vectors class. I have taught about this, how vectors can be multiplied by a number. It is called scalar multiple. So whenever you multiply a vector, let's say 5 times I cap, it means you have taken I cap 5 times. Minus 2 times I cap means you have taken I cap, but negated it and then taken that negative I cap 2 times. Okay, so I have explained it in vector multiplication. Just check it out. That lecture is there in the playlist, okay, of the channel. Okay, just go to the channel. All the playlists are beautifully arranged. Class 12th chapters are arranged: physics, chemistry, mathematics. Class 11 chapters, again physics, chemistry, mathematics. Go to the playlist. You will find all the lectures: basic maths, kinematics, integration, units. Okay, everything is there. Vector addition, vector multiplication. See, beautiful lectures are there. Cool. Okay. Now there is another way of calculating impulse, and that is via the force. And if you notice, I had mentioned the alternative definition. In fact, it comes from this formula. Force is equal to rate of change of momentum. Force, net force, is nothing but our rate of change of momentum. So therefore, that small change in the momentum will be, take the dt multiplied with the force. So it will be force multiplied by dt. Now, if you integrate both sides, this will be from initial to final. It will be nothing but, again, here also you have to integrate the force. You have to integrate that force from initial time to final time. This on the left hand side, which is initial momentum to final momentum, this will become P final minus P initial will be equal to integral of force from initial time to the final time. What is exactly this? Final momentum minus initial momentum, that is nothing but impulse. So I can alternatively write impulse as the integration of the force from initial time to the final time. This is another very important relationship. Now, because there is integration involved, so what is the next logical step? Graphs. Yeah, just check out the graph aspect of it. So if I have a graph of now force versus time, okay, keep in mind this is force with respect to time. That graph can be anything, guys, something like this. Then all the areas which are on the top above the horizontal line, they are considered to be positive area. They are considered to be positive area. All the areas which are there below the horizontal line, they are considered to be negative areas. So integration means area under the curve. So this I can also write it as, the area under the force versus the time graph. Area under the force time graph gives me the value of impulse. So force is the derivative of momentum. So when I have a graph of moment with the time, the slope gives me force, because force is derivative of momentum. So the slope gives me force. But if you flip it, and then go to the force versus time graph, then the area will give me not momentum but the change in momentum, which is nothing but impulse. Yes. Also, notice now we have got an alternative unit for the impulse. This is Newton, this is seconds. So instead of kg meter per second, I can alternatively, or I can say it is Newton into second also. So Newton second is the same as kg meter per second. Both are perfectly fine. Is that okay? Awesome. Awesome. Okay. Ritesh, why don't you put that doubt after the session is over? It will break the flow of this particular class. So that's why I always ask, please comment such big doubts. If you put, my flow of the class will go. Okay. So please put it up in the comments. I'll definitely try and reply to you. Now, after finding this particular impulse two formulas, the last concept is the concept of average force. Last concept is the concept of average force. Let me explain this to you. See, and also one more thing I wanted to tell. I'll do that also. Second. Somehow I can't remove it. Okay. Anyways, leave it. I will come back to that. Now, what is this concept of average force? Average force means when the forces are changing up, down, increasing, decreasing, it's varying. I want one constant force which will produce the same effect. So, average force, very important, guys. Average force is that constant force which produces so say for example, once you are applying 1 Newton, then 5 Newton, then 100 Newton, then 2 Newton, then 3 Newton, varying force is there. Instead of that, I say you apply constantly 30 Newton. Oh, so how did you decide 30 Newton is that force? It should be that force which will produce the same effect. What is that effect? Momentum should change, because force always changes the momentum. So the constant force which will change the momentum by the same amount, then I will say it is the average force. So average force is that constant force which produces the same change in momentum. All the effects should be same change in momentum in same time as the varying force, as the variable force, as the variable force. So if you look at it graphically, let me show it to you. Very interesting it will look. So let's say this is the graph of force versus time, force versus time. And say for example, our force suddenly goes up like this and then it comes down over here. Okay, it is a variable force. Okay, so this is nothing but your variable force. This is nothing but your variable force, as you can see over here. I want a constant force in that same time which will produce the same change in momentum. Momentum change means impulse, and impulse means area under that graph. So if I measure the area under this graph, it will give me the impulse. Is that right? If I measure the area under that particular graph, it will give me impulse. So I can say the area under that particular force versus time graph, which will give me that impulse or the change in momentum, should be the same as the area under the average force graph. The area under the average force graph. How do I ensure that? I will take the average value somewhere over here, maybe somewhere like this. Observe now. It is that constant force right over here. And I believe now it might luckily have the same area as the other one. This one. Both of them have the same areas. Like whatever missing part was here and here, it is there over here. So this graph and this variable graph have the same area. So this particular value is your average value. This is your average value of the force. Average value of the force. This is the time interval. So maybe the time interval starts from some, I don't know, maybe T1 to T2. So what is the area under that variable force? Integration. So integration of force with respect to time from T1 to T2 will give me the area under that blue one. Okay, that dark blue one, the variable force, will be area under the average force. It is a rectangle, as you can see. It is a rectangle and the height is F average and the base is nothing but T2 minus T1. This is the base and this is basically the height starting from 0. So the area under the average force, which is the area of the rectangle, will be the average force multiplied by the time interval, which is nothing but T2 minus T1. From this, we get the average forces value, which is integration of the force with respect to time from T1 to T2 upon the entire time interval, which is T2 minus T1. I'll just put it below over here. So this is nothing but average force. But what is this integration of force with time? What is integration of force with time? It is called impulse. Do you remember it? It is nothing but impulse. So might as well write this as impulse. Might as well write it as impulse. And here you put the time interval. This time interval. That's it. That is going to give me the average force value. Okay, is this clear? So this T over here is the time interval, obviously, and this J was obviously the impulse, Very interesting way. If you know the impulse, forget the integration, just divide it by the time, you will get that average force during that time interval. Cool? Welcome, Laliba. Great. Sir, when we give force to an object, then how much time does this force act on the object? It depends on you or that person or that object trying to push or pull it. So it's a matter of choice. When you apply a force, as long as you're in contact, as long as you're pulling or pushing it, that force will exist. Okay. Now, let me come to a very interesting thing of what is the meaning of impulsive force versus a non-impulsive force. Very, very important. Okay. So what is the meaning of impulsive force? impulsive force. Imagine example will be like a bat hitting a ball, or a object uh, object hitting a surface, or collision. All these are examples where you have impulsive force, and whenever you have impulsive force, you will see that graph of force versus time looks something like this. There will be no force, suddenly there will be huge force, and then you will say there will be no force at all. That is what an impulsive force means. Non-impulsive force, non-impulsive non-impulsive force means, like, imagine a, a ball pressing a spring, or an object accelerating under gravity. So in such cases, if you look at the graph of force with respect to time, you will see that the force graph could be probably like this. Maybe it doesn't change much, or might remain constant like this. It won't change much. Even for spring force, how does it change? It goes like this, kx. For gravity, it is constant. So basically, there is no sudden movement. It is usually like this and it comes down. So it is not like a spike. It is like a normal force for a long time interval. Time is long, force is small. Here time is less, force is large. That is impulsive force. Understood the difference between impulse and impulsive force, or non-impulsive force? Yeah? Yes. No, impulse and jerk, they're different things. Jerk is related to that change of acceleration, that is higher level of derivatives. That's all. Okay. Now, I asked this very famous question to many kids, and many times people fail. I hope you will not fail. Okay. So, there are two identical balls of the same mass which are dropped from the same height, on a ground surface. This particular ball number one, hits a marble flooring or some hard surface and stops within few centimeters. This ball goes into some quicksand like thing, or some soft mud, and takes some time to stop. So here it stops suddenly, here it stops suddenly, here it takes a long time to stop. This is my situation number one. This is my situation number two. As the ball falls, and when they hit the surface, their speeds, momentum, everything is same. Till this point, all the things are identical in parameters. After this, things will change. Question is, there will be some retarding force. There will be some retarding force here and here. And there will be some impulse which the ground applies. So, the question is on the retarding force after impact. After the impact, that is one thing. And the next thing that you have been asked is the impulse by the surface. Impulse by the surface, okay, after collision. Impulse by the surface after the collision. Compare this. First impulse is more or second impulse is more? And here also, first force is more or the second force is more? Okay, you have to compare. Where is the force more and where is the impulse more? Come on, think about it. Yes, kicking a ball, Chinni, is also an example of impulsive force. Whereas you taking the ball and moving like this and then slowly throwing it, that is non-impulsive, because slowly you applied the force, taken a long time and built it up. That would be non-impulsive. Laliba, the Batches for Sigma start usually in the afternoon time and they end by evening time. Okay, so you get some time in the night for studying and also the daytime if you are in a dummy school or if you are a dropper. Cool. Yes, there are usually 2 to 3 classes, 1.5 hours each with 15 minutes to half an hour break with dinner time also provided. Cool. Great. Okay. Rama saying force is same, impulse is different. Come on, I want everybody to spam the answer because I'm telling you, it is very crazy, the actual answer. The actual answer is very crazy. See, both of them, when they were hitting the surface, they will have the same speed because same height, same acceleration, same mass, everything. Okay. Finally, they stop. So if you ask me, find the impulse, if you ask me to find the impulse, it will be final momentum, which is 0, minus initial momentum, which is mv. So it will be basically minus mv. So magnitude wise, it is just mv. So whether it takes less time, more distance, less distance, nothing. Impulse is going to be the same. So the magnitude of the impulse is just going to be m into v. So actually speaking, J1 and J2 are equal. You guys are getting confused and comparing it with force. Impulse is just simple change in momentum. That's all. If you now ask me the force part, then I will say the average force is nothing but the impulse divided by the time interval. Now, I think this time interval is different. Yes, because J part is the same for both. Same for both. This time part, which is there, is more for more for 2. In the second case, it takes more time to stop. So that is the reason why this force will be less because it is in the denominator. It will be less for 2. So force number 2 will be less than force number 1. That is the answer. So this force will be less, so it takes more time to stop. This force is huge, so average force is more here, so it stops immediately within no time. So if you ask me who is impulsive and who is non-impulsive, this is impulsive, this is non-impulsive. Sudden change happened. Here, slow change happened. So this is non-impulsive versus impulsive. Got it? Everyone? Great. Laiba, I just told the classes are afternoon to evening, okay, with 1.5 hour lectures in the Sigma batch and with some breaks, including dinner time, okay, and they are on the weekdays. Sundays are usually for the class test, chapter test, part test, and full syllabus test. Okay, let's solve more questions on your screen. Here it comes. Diagrams are shown. Question is, the impulse is highest in which diagram? All the diagrams are force and time, force and time, force and time, force and time. Remember, whenever the word impulse is asked and force time graph is given, it is nothing but area under the force versus time graph. It's just simply the area under the force and time graph. So let's try to figure it out one by one. What is the area over here? Half base into height, which is 0.5. So half is also 0.5. So this will become 0.25. Here, base into width. So it is 0.5 multiplied by 2, which is just 1. Here, it will be half. It's a triangle. Base is 2. Height is 0.5. 2 cancel. So it will just become 0.5. Here, if you see half, base is 1 into 0.75, that is 3 by 4. So it will become 3 by 8 basically. It will become 3 by 8. So question is, which is highest? The highest is B because this is less than 1, this is also less than 1, this is also less than 1, this is the highest. So B will be the highest, which is 1. So hence the correct answer for this particular question is option B. Okay, how many of you wrote option B? Very good, Rama. Dilip, excellent. Dilip joined in, I guess, late. Yes, Chinese, that is the perfect answer. Moving on to the next question coming up on your screen. Here it comes. A force graph is given. The linear momentum between 0 and 6 seconds which it gains is how much? See, read the question again. The linear momentum gained. means change in momentum, means impulse, means area under force versus time graph. Oh, you just have to figure out the area. So you have to think logically what it actually means, but they have rephrased the question in a slightly different way. Okay, let's start. This particular area, first part, is positive, so it will be plus height 2, base also 2, so 2 into 2, which is basically 4. This part is also positive, it's on the top, height is 1 unit and base is 2 units, so this is 2. This particular part is below, so negative, height is 1 and base is 2, so it is minus 2. So the total area will be 4 plus 2 plus minus 2. So it will just be 4. Hence option B will be the right answer. Everybody got it? How do we find the change in momentum, which is impulse, which is area under force and time? Very good. Amazing, amazing, amazing. Evenings and night not possible, Laiba, because many teachers are YouTube teachers also, and we also have YouTube classes. So it's not extreme night. And whatever classes you in case are not able to attend, say one, not all classes are in the afternoon. Let's say few classes you miss. You can watch the replay. Number one, you can watch the replay at higher speed, which is actually better. Number three, there is also doubt solving in the replay mode also. That part is also there. So actually it's good, no? You will save a lot of time. You are watching it faster. So I think just one class you dedicate every day. I have to finish it. It's 1.5 hours. Okay. Lot of students do that. Next, the figure shows time force graph. The average force is how much? Question is, what is the average force? Now, by the definition of average force, whenever I put triangular brackets, it is average. It is nothing but impulse divided by the time. I think I know the time here, but impulse I don't know. But impulse I can find from a force graph. It is nothing but area under the force versus time graph, and this is nothing but t, which is time interval. This is nothing but time interval. This formula I just showed it to you over here. This formula I just showed it to you over here. Impulse divided by time is nothing but the average force. Okay, cool. So what is the area under the graph and what is the time interval? Time is from 0 to 0.4, so it is 0.4, of course. It is a triangle, so half multiplied by the base, which is again 0.4, multiplied by the height, which is 100. 0.4, 0.4 cancels, 100 by 2 is nothing but 50. So 50 Newton is the average force, which is option B. Wow, everything is B for IIT Bombay. Okay. Great. Amazing. 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 All right. Hi, Smiley Queen. Welcome aboard. Great. Let's move. Next question on your screen, and here it comes. A bullet of certain mass of 10 grams leaves the barrel of a gun. So, small bullet starts from rest. The gunpowder explodes. The bullet gains momentum, and it comes out with a big speed, 600 meters per second. If the barrel of the gun is so much long and mass of the gun is so much, then the value of the impulse supplied by the gun will be how much? I feel most of the data is chumma given to confuse you and to fool you. Just think like this. This bullet which is there of 10 grams, which is 10 into 10 to the power minus 3 kg, it was at rest. It slowly will accelerate, and it will accelerate inside the barrel of the gun. This is that barrel of that particular gun, maybe. Okay, this could be that gun. Okay. And by the time it comes over here, it has a speed of 600 meters per second. Question is, find the impulse given by the gun to the bullet. So obviously the bullet experiences an impulse in this direction, and that impulse is nothing but change in momentum, which is final minus initial. So final momentum of that bullet will be the mass into final velocity, and this will be mass into initial velocity. Mass is sorry, not point, it is 10 into 10 to the power 3 minus 3. Final velocity is 600. Initially, it was at rest, so 0, correct? So this is nothing but going to be 10 to the power minus 2 multiplied by 600. So two zeros and minus power will cancel. It will just become 6. But this is impulse, kg meter per second or Newton second. Anything will do. So 6 is there over here. So this is the right answer. Got it, guys? How do we solve it? So you might be wondering, sir, what do I do with this? And what do I do with this? It is useless data. Useless data to confuse you. Useless data to just confuse. Many kids will get confused in the actual JEE paper. They'll think I did not use, I've done wrong. They will again recheck, waste time. And then they will always be doubtful. Next question also, they will be thinking about this question. Oh, I think I've missed something. Something is wrong. Again, they will come. Waste of time. So you should understand, not all questions, some questions definitely will be of this type. Okay, perfect. Hi, Samuel. Welcome, man. Welcome everyone out here. All right. Moving on, next question, guys. We are on a sprint mode now. Full on, many questions, one after the other, one after the other. Average force is applied on a machine gun firing some bullet of 10 grams at this speed to keep it in position. The number of bullets fired per second by the machine gun is how much? Now, these kind of questions are very, very common, where you will see that there will be some bullet and it has been fired. It will get some velocity. This particular mass will be at rest, and because it is getting some velocity, therefore there will be some impulse on it, and because of that impulse there will be some force on it on an average. There will be some force on it on an average. So if you ask me, what is the impulse for one bullet? If you fire one bullet, the impulse for that one bullet will be final momentum, which is mv, minus initial momentum. So it will just be m into v. So if you fire n number of bullets, okay, then the total impulse will be n times of any impulse for one bullet. So it will be nothing but n into mv. So that will be the total impulse if you fire n number of bullets in time t. In time, let's say t. Once I know the impulse, I think we can figure out the average force. So the average force acting on it will be that impulse upon that particular time. So impulse is nmv and time is t. Now that's it. That is my solution. Average force is nmv divided by t. This is the formula. If you remember, most of the problems will get solved. Here n by t is asked. So therefore, if n by t is asked by the examiner, it will be average force divided by mass into velocity. Average force is 125. Mass of that bullet is 10 grams. So 10 into 10 to the power minus 3, and velocity is 250. That's it. So we get the answer now. 125 goes with 252 times. So this will be 1 by 2. This will become 10 to the power minus 2. That's it. So 1 by 2 is 0.5. Minus 2 power on the top will become plus 2. So this will just become decimal shifts by 2 places. It will become 50. So 50 bullets per second. 50 bullets per second. Number of bullets per unit time. Hence the answer is option number 2. Got it, everyone? Wow, everything is 2. Hi Sudhar, thank you so much, man. Sir, in the before question, we want impulse of the gun. Tell me one thing, won't it be the same? Impulse will be equal and opposite. Where is that previous one? It is impulse by the gun or to the gun, doesn't matter. This is very, very important. Good you raised that question. So, impulse on the gun will be equal to impulse on the bullet by the gun. Here it will be by the bullet. One is this way, one is the other way. That's it. This is following Newton's law of motion. Which one? The third law. The third law of motion, action and reaction. If this much force is applied here, same equal and opposite force is applied on the other side. Cool? Make sense? Right. Sir, in chapter 1, do you teach errors and measurement? Yes, already I have taught errors and measurement. If you have not seen my lecture in the playlist, please check it out. It's there on the channel also. See, I have already done significant figures, vernier calipers, micrometer, okay, units and dimensions, everything has been done over here. Okay, so please check it out. Great. Very good. Dilip, all clear? Yes, option 2 is the right answer. Perfect, man. Perfect. Option 2 is correct. Yeah, nothing wrong. Yes, see, it is 50 only. Cool. Moving on to the next question. A machine gun fires so many bullets at per minute with a speed of 100. The recoil velocity of the gun is how much? Per minute or this much. Machine gun of this much mass. Okay. Now, in this particular question, actually, this is now going to slightly go towards conservation of momentum. But since I just told you about this particular concept, I think we will be able to still solve it. And I'll tell you how. Okay, observe. See, if this gun of so much mass fires this much bullets per minute with this much speed, can we figure out the average force on the bullets? I just gave you the formula, number by time into mv. Number of bullets per unit time, you are firing 180 bullets per minute, that means 60 seconds. Mass of each bullet is 20 grams, so minus 3 multiplied by what is it? Velocity, which is 100. Okay, which is basically 100. Perfect. Yeah, everyone. Now, whatever force is there on the bullets, by Newton's third law, won't it be also the force on the gun? Won't it be also the force on the gun? Think about it. And this particular force which is there on the gun, this force will be also the impulse on the gun, and remember, impulse is force by time. Force multiplied by time. So if impulse is force multiplied by time, impulse is nothing but force multiplied by time. If I know that particular force, I can find that impulse. I can find that particular impulse from this. So that impulse will give me the velocity. Okay, till this point, let's figure out how much is this value, then we'll go ahead. Okay, so how much is this basically? This is nothing but 3 times. Okay, and this is 3 zeros here and 3 zeros here will cancel. So this is coming out to be 6. So 6 Newton is the average force on the bullets, which is also average force on the gun. Now we can also say impulse on the gun. Impulse on that gun is nothing but our average force on that particular gun multiplied by the time. How much is that average force? 6. How much is the time? It is 60 seconds. So impulse is nothing but change in momentum. Final momentum will be mass of the gun multiplied by velocity, and initially it was not moving at all. So what is the mass of the gun given? It is clearly given as 10. What is the velocity given? I have to find it out. So 6 into 60 means 360. Therefore, my velocity will be nothing but 36. So, velocity will be nothing but 36 if I'm not wrong over here. So, I think something is wrong over here, but otherwise everything was fine. Yeah, 20 grams, I think bullet mass, 10 is over here. Okay, per minute, 180 bullets per minute. Okay, 100 meters per second, minus 3 and plus 3, 2. Yes, this will go 3 times. 3 twos are 6 Newton. And this 6 Newton is the force. So force into time will give me the impulse. So this much force was there for, on an average, let's say for 60 seconds. So you can say that. Okay, so that will give me 36. I hope that is clear. Okay, yes, 36 is coming. I don't think the options are matching. Maybe there is a misprint over here. So let's ignore this particular options. But yes, 36 is the right answer. Cool, perfect, everyone. So this is the kind of questions that you can get in impulse, momentum, and average force, area under the graph, slope, etc. So very, very important slides which I have made for you in beautiful manner. Okay, ready guys for the next part now? Ready for that next part? Ready for the next part? Okay. So what is the next part? It is the law of conservation of momentum, which is like the basis for not just this chapter, but so many chapters are there where you will need this concept in the problem solving. Very, very important law. And it is a universal law also. And it is a universal law also. So what is this law of conservation of momentum? It says maybe you have some particles having some momentum and something happens to them and they change their directions, their speeds. Okay, maybe they join their masses, they explode, anything could happen. So this was my system before. This was my system before some explosion, collision, interaction happens, and this is the system afterwards. But during this process, the most important thing is from outside, external force is not there. External force is zero. Okay, so if you add up all the forces from outside, it is zero. Internal forces does not matter, so don't waste your time. If you choose a system, spring block system, two balls colliding as a system, car colliding with a truck system, a bullet getting embedded in a block system, all these systems, if they are colliding also, the collision force, explosion force is an internal force. So I'm making that note over here. Okay, so collision or explosion, all these are internal forces, these are internal forces, and they don't matter. Okay, so whenever you see external force is zero, internal force is not bothered, then if you count the total momentum of the system initially and you count the total momentum of the system finally, this is the total momentum before and the total momentum before and after, sorry, they will always be equal. That is the law of conservation of momentum. As simple as that. The momentum of the system before and the momentum vector sum, okay? So they could be in 1D, 2D, doesn't matter, and after will always be equal. So this is the law of conservation of momentum. In mathematical terms, statement terms, formula terms, diagram terms, whatever you see. Now let's see how do we apply it. There are many examples of this. And the very common example is the example of recoil. And just now only we discussed it. Imagine you have a gun, okay, like this, and there is a bullet inside it. Right now, if you see this entire system is at rest. Entire system is at rest. So the total momentum initially is obviously zero. The bullet is fired from the barrel of the gun. The gun will recoil. Recoil means it will move backwards. If you have tried shooting in some fun fair or maybe some adventure competition, whatever, you would have felt one force suddenly comes on your shoulder as if the gun is trying to go back, because the bullet pushes the gun back by Newton's third law and then propels forward. So you will see that the bullet will come out from here like this. The bullet will come out from here like this. My system is still the same. And believe me, the total momentum finally is also zero. If you are wondering how, observe this. The final momentum of the gun is mass of the gun into velocity of the gun, but it is minus. The momentum of the bullet is mass of the bullet into velocity of the bullet, but it is plus. If you add them up, that will be zero. This minus and plus comes because they are vectors. So if you take this over here, you can easily figure out what is the recoil velocity. So therefore, mass of the bullet into velocity of the bullet will be equal to mass of the gun into velocity of the gun. This is usually called as the recoil velocity, and usually this is called as the muzzle velocity of the bullet. Muzzle velocity of the bullet. Muzzle velocity of the bullet. This is called recoil velocity of the gun. Is this absolutely clear how we applied law of conservation of momentum? This system, the gun applying the force is an internal force. From outside, nothing was there. So the gun will fly this way, the bullet will go this way, unless somebody is holding the gun. So if nobody is holding the gun, the velocity with which the gun moves behind is called the recoil velocity. That is, if nobody is holding. If somebody is holding, obviously the speed will be zero. So this gun's momentum is negative. The bullet's momentum is positive. Negative number plus positive number will add up to give me zero, which is the total momentum of this system. Clear? Everyone? Hi, good evening, Lakshmi, everyone. Awesome. Error analysis and propagation is also there. I think maybe if that lecture is missing from the playlist, I will add it. But you can search for it, Pritija. It is there on the channel only. Another example of conservation of momentum, I can tell. Say there is a ball of certain mass. It is going with some velocity u1, and maybe it collides with some another mass m2 of velocity u2. Now this is my system. This is my system. And in this process, after collision, what might happen is maybe this mass m1 might continue moving like this, maybe with a velocity v1, and this mass m2 might move like this after the collision. It might change the direction also. That depends from the masses and velocity and all of that. So this is before and this is afterwards. So this is after collision. After collision. This is after collision. So momentum should be considered. What is the initial momentum? It will be m1 u1 will be positive, m2 u2 will be negative. Here the final momentum will be m1 v1. Here also you will have m2 v2 in the positive direction. They both will be equal. If this velocity was this way, this will be plus. If this velocity was like this will be minus. Okay, that's all. So I think I put m2 by mistake. This was m1 v1. v1, v2 are the final, u1, u2 are the initial velocities. Is that absolutely clear how law of conservation of momentum is applied to particles, recoil? Multiple examples are there. Okay. Yep. So this law confused me so many times when I'm solving Tattva and relied on this law. It's used, no external force, correct. If momentum is always conserved in an isolated system, why does a ball thrown upward come back down? Space Tech, tell me, when you choose ball as a system, is the external force zero? Obviously not, gravity is there. So how can you say conservation of momentum will be valid? Got it? So momentum is conserved for an isolated ball is not an isolated because there is an external force acting on the ball. Gravity, mg. So you cannot conserve momentum. But for a ball earth system, yes. So when you throw the ball up, the earth moves down slightly. Earth being massive, the recoil velocity will be very less. But yes, ball earth momentum will be conserved. Got it, everyone? Laiba, I hope now it is absolutely clear. Rama, everyone out there. Now, even when the momentum is conserved, there is one another fact which you should know. Energy may or may not be conserved. Mechanical energy, that is. Mechanical energy may or may not, depends, may not be conserved. That particular part we will see later on in the next class, where we'll be seeing elastic, non-elastic collisions. But for now, remember mechanical energy, okay, may be may not be conserved, depends from situation to situation. All right, cool. So maybe we can take one question coming up on your screen like this. Say you have a mass which is moving with some speed u, and in front of it there is a huge mass of mass 3m. The mass m sticks to 3m. Sticks to 3m. Find the common velocity afterwards. Find the common velocity after they get stuck to each other. Okay, that is the question. Let's think, how do we solve it? In this particular problem, do you agree that if I take this as my system, there is no external force? External force is zero. So therefore, I can say momentum is conserved. Momentum is conserved. So I'll just put an equal to, and I'll see how much is the initial momentum first. Initial momentum is that mass into velocity. This guy was at rest, so 0. As they stick to each other, it is clearly mentioned. So that new mass will be 4m and it will be moving with some new velocity. So that final momentum will be 4m multiplied by v. So as you can see, mm cancels and I will get v is equal to u divided by 4. That is the answer. So when it gets stuck, the new speed with which the total mass will go will be u by 4. Yep. If I now ask you a follow-up question, it's not given, but if I ask you now a follow-up question, okay, a follow-up question is, what is, can you find the loss or gain of energy? Lot of times people have this doubt that, sir, energy is always conserved. What are you saying? Momentum is conserved, energy is not conserved. I don't believe you. Okay, let's try it out. Now we conserved the momentum, everything, and we got this velocity as u by 4 already. Okay, in the previous part. In that previous part, we already got it as u by 4. So let's figure out what is the initial energy. So what is the initial energy? It is half m u square plus it is at rest, so 0. So it is just half m u square. What is the final energy? It will be half, mass is 4m and velocity is u by 4 and this whole square. So this will become 4 by 2, which is 2, so 2m, and this will become u square by 16. So this will become 2 and 16 cancels, becomes 8. So it will become mu square by 8. Mu square by 8 versus half mu square. Obviously, this is less. As you can see, this is definitely less than this. So definitely there is a loss of energy. So the loss will be the bigger value, half mu square minus mu square by 8. The LCM is 8, so 8 is here. So it will become 8 mu square minus mu square. 8 minus 1 is 7. So it will become 7 by 8 mu square. So that is the loss of energy. So energy may be conserved, may not be conserved, like I said before. Got it? Okay. Space, that's a very good question. And when I teach modern physics, I explain the concept of how even photon has momentum and how the formula of momentum is no longer same for quantum particles. So the formula of momentum is m into v for matter, but for photon, it is not mass into velocity because mass of a photon is not defined and you cannot see a photon at rest. So you assume the photon's rest mass is zero and all of that. So you cannot apply m into v formula for a photon. So you go by Planck's constant by lambda as the momentum of photon, and then you can apply conservation of momentum. So it's a very interesting concept. We deal with it in modern physics, and if you were a part of Sigma batch, you would have heard from me and when I explained that concept beautifully. Yeah. Okay. Sir, 3 mu square is it? Did we? Sir, one mistake. Where did I do a mistake? Oh, 3 mu square. Oh. This 4 by 2 is 2. U by 4, u square by 16. 2 by 16, it will become mu square by 8, correct? So half. Oh, sorry. I made a mistake. Yes, calculation mistake. Sorry, guys. Sorry, my bad. My bad. Yeah. So LCM was 8, perfect. But this was not 1, this is 2. So this will be nothing but 4 times mu square minus mu square. 4 minus 1 is 3. So it will become 3 by 8 mu square. So that is the loss. Perfect. Okay, good. Perfect. You guys are paying attention. I'm proud of you. Amazing, guys. Amazing. Let's do the next question on your screen. A boy of mass is running with some speed. He jumps over a cart while running. Find the velocity of the cart after the boy jumps. Let's draw everything so that we get a pure feel of it. This is that cart before and afterwards. Okay, imagine this is the ground surface like this. Okay, before the cart was at rest, eventually the cart will start moving because this Pandu over here who was running with some speed jumped on that cart and he just stood there. Okay, and just stood there, and both of them are now going to move. So I feel it's a question of conservation of momentum, because if you take this as a system, him applying a force on the cart is an internal force. Now he will push the cart, that is internal, cart will push it, internal force. Externally nothing is there, it's on a smooth track, I believe. So initial momentum will be equal to the final momentum. Mass of this person is 50, velocity is 2, the cart was at rest, so 0. Finally, they became one singular mass. So the mass will be 50 plus cart mass is 2 multiplied by the common velocity, which is v. Is that clear, everyone? So therefore, what we'll have is 100 is equal to 52 times v, or v will be nothing but 100 by 52. That's it. So how much will it be? It will be slightly less than 2, no? 52 twos are 104. So 100 is less than 104. So it will be 1.9 something. There is only one option like that, and I can see it is option labeled B. Perfect. That is the answer. Okay. Very good, Dilip. Yes, Shankar. Amazing. Shashank. Sir, what is PCM? What is PCM means? You don't know, PCM? Which standard are you in? Shashank Singh. Which standard are you in? Hello. Premila, welcome aboard. Yes. Which standard are you, man? Come on, tell me. Let's do the next question on your screen. Here it comes. Get ready for it. P for physics, C for chem, M for maths. What else? Okay. A car with some mass traveling rear ends of another car. The second car was traveling with some speed. After the collision, 1000 kg car is moving with some speed. What is the speed of the other car? Okay, beautiful question. I think it's something related to like this. Where did it go? Here, this one. It's somewhat like this. Somewhat like this kind of scenario. Okay, so let's draw the diagram first. So we have a car of 1500 kg. So this is 1500 kg car, which was already moving with 25 meters per second. It rear ends, so means it hits from behind another car of 1000 kg, and it is traveling in the same direction at a smaller speed. Makes sense. So the front car was moving slowly. This car was moving fast, so it hits from the rear behind like this. And then this is my system before. This is my system before. So afterwards, what happens is this 1500 kg car, after the collision, the 1500 kg car speed is asked. Okay, so I don't know. But this 1000 kg car, that guy's speed is given, is moving in the same direction at 22 meters per second. 22 meters per second. So this is my system after the collision. So it has gone from this to this. Just conserve momentum. Nothing is there. Before and after momentum will be equal. Okay. Initial momentum will be 1500 multiplied by 25 plus 1000 multiplied by 5 is equal to 1500 multiplied by V plus 1000 multiplied by 22. Only thing remaining is V. You will get the answer. So doing the calculation, I think you get it as 20.3 if I'm not wrong. Okay, so you should get it as 20.3 meters per second. Very straightforward kind of thing. Very straightforward kind of thing. Is it right? Everybody? M1 V1 plus M2 V2 is equal to M1 V1 plus M2 V2. Yeah, yeah, yes, perfect. Sir, it is not 5, it is 15. Oh, sorry, I wrote 5. Yeah, sorry, this was 15. My bad. 1000 into 15. Yes, thank you so much. Perfect. Let's do some better questions now, which are coming up on your screen. This kind of questions are slightly on the higher side now. There is a bullet of certain mass traveling with some speed, passes through a block which is at rest. The bullet comes out from the other side with a lesser speed. Goes in at 500, comes out at lesser speed. The block slides so much before coming to rest. Find the friction coefficient. Wow, crazy question, guys. Let's draw the diagram. This was initial. So afterwards, what will happen? Let us draw it. So this block will start to move. It will get some velocity over here. And this particular bullet which is there, this particular bullet which is there, that is also coming out from here. After this, on that same surface, this particular block moves ahead and it stops. And it basically stops. And it basically stops. So it has moved some amount. It has moved some amount. And that is exactly that question. That is that question. If it has moved so much, what is the coefficient of friction? It has moved 20 centimeters. That means 0.2 meters. It moves from here to here. Okay. What else data is given? The bullet's mass is 20 gram. So it is basically 20 multiplied by 10 to the power minus 3 kg. This was given to be at rest through a block initially at rest given, and it comes out of it at 100 meters per second. So this is also given 100 meters per second. Is this velocity given? No, it is not given. So I think my job now is to figure out how much the velocity is after the bullet passes through it, and then use this velocity and Newton's laws and maybe kinematics to figure out the coefficient of friction. So I think it's a multi-step problem. We will do this part first and then we'll do this part next. Okay, so I'll create a duplicate slide and let's see this. In this process, from the bullet entering in till it goes out, this is where the momentum is conserved. Momentum is conserved during the collision, during that particular collision. So I'll put an equal to over here. Okay, I'll just put an equal to over here. I'll put the initial momentum on this side. Initial momentum is mass of the bullet, which is 20 into 10 to the power minus 3 multiplied by velocity, which is 500 plus 0 because the block was at rest. Okay, everybody with me? Y plus 0. This is the momentum of the bullet. So plus 0 will give me the initial momentum. Final momentum will be mass of the block, which is 10 kilos, into velocity, which I do not know, plus mass of the bullet, again 20 into 10 to the power minus 3 into 100 meters per second. I think we can bring this term over here. So it will become 20 into 10 to the power minus 3 multiplied by 500 minus 100 is equal to 10 multiplied by V. This will therefore become 2 into 10 to the power minus 2 multiplied by 500 minus 100 is nothing but 400. So into 400 is equal to 10 multiplied by V. Minus 2 and these two zeros will cancel. So 2 fours are 8 is equal to 10 times of V. So V will become 0.8 meters per second. 0.8 meters per second. Is that right, everyone? Yes, perfect. Till this point, absolutely clear. Give me the answer in the chat box. Understood? Yes or no? Okay. We will use this for the second part from here to here. And how? I'll tell you. Weight is there, normal is there, friction is there. That kinetic friction is going to do negative work and it is going to stop it. Is that right? So the work done by the friction is the change in kinetic energy. I can use work kinetic energy theorem. So work done by the friction is final kinetic energy minus initial kinetic energy. I can put K final minus K initial. Work done by friction is the frictional force multiplied by displacement but with a negative sign. Why? Because friction and displacement are opposite. Final energy is 0. Initial energy is half mass into V square. Friction is mu into m into g into displacement. And this minus will cancel. So it will become plus over here on both sides. And best part, that mass is now irrelevant because it just got cancelled off. So I just want the value of mu, right? Okay. Mu into g is 10. Displacement is 0.2. Displacement is 0.2. This is half multiplied by v square. The velocity, we just got it over here. It is 0.8. Velocity is 0.8. So I'll just put 0.8 square. That's all. So from this, we'll get the answer. 10 into 0.2 is just 2. So this 1 by 2 and this 2 will also come below. And 0.8 square is 0.64. So therefore, mu will be 0.64 divided by 4. 64 divided by 4 is 16. So it will be 0.16. That is the answer. 0.16. Yes, Dilip, it is the correct answer. Okay. Teamwork, all right. I've noted that. I'll definitely think about it, man. Okay. Yes. Perfect. Sir, we can also use work energy theorem for finding the velocity. Yes, yes, that's what we did. Space. The longer way will be Newton's law, then finding deceleration, then using kinematics. Multiple steps will happen. So for such a problem, imagine doing it like that will be crazy. I wouldn't recommend it. So first step was conserving moment. Second step was the previous chapter work kinetic energy theorem. We got the answer. Is that right? Let's go to the next question, guys, coming up on your screen. There is a man of mass standing on a plank of equal mass resting on a smooth surface. The man starts moving on the plank with a speed u relative to the plank. The speed of the man relative to the ground is how much? Amazing question, guys. It can be very confusing if you do not do it properly. Okay, perfect. Let's see. So, the man's speed is given with respect to the plank, and the plank speed is not given. That's the first step I believe we should do. The speed of the plank. This is the speed of the plank with respect to the ground. With respect to the ground. And this person's velocity is also given. This is u, but relative to the plank. I think I'll use the concept of relative velocity. So, relative velocity of man with respect to the plank is velocity of man minus velocity of plank. Velocity of the plank. Relative velocity of the man with respect to the plank is negative u. Velocity of the man, I do not know. Velocity of the plank itself, velocity of the plank itself, I've assumed it as v. Is that okay? So from this, we will get Vm, velocity of the man, as minus v becomes plus v minus u. This is the first step of the problem. This is the first step of the problem. We got velocity of the man as v minus u, but that is not the answer. I can leave it because I do not know what v is. So I apply my brain and think, before the person started moving, the system was at rest initially. So total momentum was 0. So this is very, very important. Initially, that man plus plank system was at rest. So initial momentum will also be 0. So initial momentum should be equal to the final momentum. And what is that final momentum going to be? The momentum of the man plus momentum of the plank. This is final. This is the final. So therefore, 0 is equal to, what is the momentum of the man? It is mass of the man, which is m, into velocity of the man, but he's going left side. He's going left side, so minus, plus momentum of the plank. Plank also of the same mass, so m into velocity of that plank. So minus mv comes on this side, so it will become m into vm is equal to m into v. Mm cancels, so vm is equal to v. But wait a minute, vm, I just got it here. Vm is v minus u. Vm is v minus u. Is that right? Vm is nothing but v minus u. Now this is the catch. Many people make a mistake here and they say vv cancels, u is 0. U is 0. If u is 0, then the whole problem will fall. And if you see over here, the answer is not 0, it is something. So v, while doing this problem, usually I have seen people make a mistake. See, the mistake happens in this part. Here, understand, when I put minus u, I have already made that assumption that everything on the left side is negative, right side is positive. This person is walking like this. The person is walking like this with u speed relative to the plank. So when I put minus u, it is already assumed that left side is negative, right side is positive. That means whatever Vm I have got, when I substituted velocity of the man, I put plus over here indirectly. Indirectly, when I had put plus over here, that means what? I have assumed the velocity of the man to be on the right side, which is wrong. I know the person eventually will be moving towards the left side. So the catch is many people miss this minus sign. Many people miss that minus sign. Okay, this person will actually be moving on the left hand side. So when you do that, then you will see this will not be v minus u, rather this will be u minus v, and that is what you will substitute over here as u minus v. Now you will get it. U will be equal to 2v, okay, or v will be equal to u by 2, but that is not the final answer which is asked. We have been asked what is Vm. So Vm will be u minus v, which is itself u by 2. So it will be u by 2. So u by 2, which means B is the right answer. Perfect. So there is lot of chance of making a silly mistake. That's why it's a good question. Why this is minus? Because the person actually will be moving left, the plank will be moving right. So that minus is very important. Cool. Okay. So I have kept one homework question for all of you. I think you will be able to solve it. It's based on that bullet and all of that, or something like the balls being fired like the bullet. So solve it, very easy. Answer is there on the next slide along with the solution. I will not show it to you over here right now, but you can download the PDF after some time. Okay, you can download the PDF after some time, and on the description box you will see the link. Okay, cool. I hope you enjoyed the class, learned a lot of new concepts, and how tricky it can get, especially some small things here and there. So conceptual chapter, next lecture we'll do elastic, non-elastic 2D collisions. Okay, and coefficient of restitution. Bye bye. Take care. Have a great time, guys. This was Captain Shreyas signing off. Okay, do not